Now let us see another example on a composite bar. So here the composite bar is a copper rod of 30 mm diameter is enclosed in a steel tube of 45 mm external diameter and 5 mm thickness. The length of the composite bar is 2 meter. A mass of 50 kg is allowed to slide down freely through a height of h. So a composite bar is there and a mass of 50 kg. So it will slide along that particular bar through a certain height of h, and maximum instantaneous stress is not to exceed 75 MPa. Find height and elongation of the composite bar. For steel, modulus of elasticity is 200 GPa, and EC, that is for copper tube, the modulus of elasticity is given as 120 GPa. Now, copper rod is solid, so its diameter is given as 30 mm, so it is pi by 4 dc square. For steel tube, the outer diameter is given as 45 mm and thickness is 5 mm. We know the relation between outer diameter and inner diameter. DO is equal to DI plus 2T. So T is the thickness. DO is in mm, thickness is also in mm. So DI will be in mm. So DO is 45 minus 2 times thickness. Thickness is 5. So it is 35 mm. So area of steel will be equal to that of the area of the hollow tube, that is pi by 4 do square minus di square. So it is pi by 4 into 45 and square of that minus 35 and square of that. So that value comes out to be 628.32 mm square. The diameters they are in mm, so and square of that, so that value will be in mm square. Area is always in mm square. Now we know that the strain in steel has to be equal to strain in copper for the that this is the basic condition for the composite bar. Now we know that stress is directly proportional to strain, so sigma upon E, capital E will be equal to small e. So E is equal to sigma upon E, that we have substituted over here. So stress in steel divided by modulus of elasticity of steel is equal to stress in copper divided by modulus of elasticity of copper. So E is equal to sigma upon E. This is our Hooke's law. So that we have used and substituted over here. But this is in MPa. This is these two terms they are in GPa. You can convert them MPa by multiplying by 10 raised to 3. So here also you can multiply by 10 raised to 3. Here also you can multiply by 10 raised to 3. That has got cancelled. So we have written only 200 upon 120. So value of sigma s comes out to be 125 times 125 MPa. Now here we know the value of stress in copper and therefore we are getting directly the value of sigma x. Otherwise we could have got the value of sigma s in terms of sigma c. Now mass is equal to 50 kg, but we know that relation between weight and mass is W is equal to mg. So 50 into 9.81, that is 490.5 Newton. Total elongation will be equal to elongation of copper or elongation of steel, whichever the value that will take, the answer will be same, because for composite bar the elongation of the bar should be same. So substitute the values. Sigma is in Newton per mm square or MPa, length is in mm, and modulus of elasticity is in MPa or Newton per mm square. So delta L comes out to be 1.25 mm. Strain energy stored will be strain energy stored by the copper plus strain energy stored by the steel. As their copper and steel are the two materials, they will store different strain energy. So total strain energy, that is W into delta, or W into, in place of delta it is H plus delta L. So strain energy is W into delta, and in place of deformation it is the height through which it is falling plus the deformation of the plate or collar, that plate that will take place. So and UC and US are nothing but the strain energy stored in copper plus strain energy stored in steel. Volume is area into length. So W as it is. H we have to find out. W is 490.5, delta L is 1.25, sigma C Newton per mm square and square of that 2E, modulus of elasticity is 120 into 10 raised to 3. Area is 706.85 and length is 2000. For steel, it is 125 square divided by 2 into modulus of elasticity is 200 into 10 raised to 3. Area of steel is 628.32. That is the hollow tube which we have calculated that area already, and length of the composite bar is 2 meter, that is 2000 mm. So length is same. So H will be equal to. So first calculate this term. Divide this entire term. Do the calculation of this entire term, which is nothing but the numerator that we have written. Divide by 490.5 and then subtract 1.25 from that. Whatever the answer that you will get, from this answer you have to subtract plus 1.25 will go on other side, it will be minus 1.25. So that answer comes out to be 166.37 mm.